Hi everyone, in this video I am going to explain about figure of merit of galvanometer or current sensitivity of galvanometer. Figure of merit means current required for unit deflection, that is to move the needle from 0 to first division. How much current required is called current sensitivity or figure of merit of galvanometer. In this video, I use half deflection method to find figure of merit of galvanometer. This is the required circuit diagram. The required apparatus are battery of 1.5 volt EMF, two resistance boxes, one is of 11,100 ohm and another one 110 ohm, and one galvanometer and one one-way key. Now I will explain you the connections. Connect one wire from positive terminal of the battery to the any one end of the galvanometer. Here no polarity, there is no plus and minus. From the same end, connect one wire to the key. Opposite end of the key is connected to the small resistance box, and one wire is taken from the opposite end of the resistance box and it is connected to the other end of the galvanometer. Take one wire from the same end and connect to the resistance box R, and the other end of the resistance box R is connected to the negative terminal of the battery. And finally, connections are look like this. Now I will explain you how this apparatus will help you to find figure of merit of galvanometer. At first, note down the EMF of the battery, that is 1.5 volt. In your supply battery, the value is written here 1.5 volt. Switch on the battery and open the key K1. Now you will find deflection in galvanometer. It is around 29. Set this deflection to even deflection by adjusting the values of R like this. Here I plugged 2000 key, so the galvanometer reading will turn to 21. I want even deflection, so I have to adjust these keys. Here I set needle to 28th division by unplugging 100, 200 and 5000. So total resistance applied is 5000 plus 200 plus 100, that is 5300. Note down this value in column R. The value of resistance R for first trial is 5300. And the even deflection is 28. Now close the key K1. So galvanometer shows null deflection, that is 0. Now set the galvanometer deflection to half of the original deflection, that is half of the 28, that is 14, by adjusting small resistance box yes. See here, I am unplugging 50 ohm, or I am applying 50 ohm resistance So needle will move to ninth division by adding resistance. I can adjust to 14th division. Now I got 14th division. Now count the values: 50 plus 20 plus 20 plus 10 plus 5 plus 2. You have to count all the values in front of the hole. Now I got 107. Note down these values: 107 ohm in your tabular column in the place of yes, 107. Now I am explaining you how to do the second trial. For that, remove the key K1 again. Now deflection shows 28, what you set for the first trial. Now adjust this deflection 28 to 26 by adjusting the resistance box R. Here you can see galvanometer reading is adjusted to 26th deflection by adjusting the value of R. Now total value of R is 5000 plus 500 plus 200 plus 100. It is total 5800. In your first column, please note down this value. That is 5800. For the deflection, theta 26. Now by placing the key K1, you have to get half of the original deflection, that is 13. Here you have 13th divisions already. That means the unplugged resistance box is same. Now note down the value of small resistance box yes as previous, that is equals to 107 only. Now the calculation, first write the formula K equals to E divided by R plus G into theta, where E, EMF of the battery, that is 1.5 volt, which is constant for each trial. R, resistance of the resistance box R. For the first trial we have 5300, and G, galvanometer resistance, that is equals to resistance of the resistance box S. That is for first trial I have 107, and for first trial theta is deflection, that is 28. Substitute here in the place of theta 28. By simplifying this, I'll get values like this, and I converted it into 10 to the power. It is 9.9 into 10 raised to minus 6 ampere per division. 10 to the power 6 is equals to micro, so I can write 9.9 micro ampere per division is the figure of merit of our galvanometer. I mean, if 9.9 micro ampere current flows through this galvanometer, it will show 1 division. For the second trial, you can write the same formula and substitute the values. 1.5 is same. The variation is in R. that is 5800 for second trial, but value of S is again same 107 only. Deflection is 26. By simplifying this, I got 0.00009766, and I can write this number as 9.76 micro. So the unit is microampere per division. Now fill these answers in your tabular column. That is 9.9 into 10 to the power minus 6 and 9.76 into 10 to the power minus 6. Now take the average of these two values and give the result as figure of merit of galvanometer. Resistance of the given galvanometer G is by calculating the average of these two values is equals to 107, and the average of 9.9 and 9.76 is 9.83 into 10 to the power minus 6 ampere per division.